Okay, so on this section, chapter 5, section 6, it's called linear programming, okay? So it's called linear programming. You'll also hear it as optimization problems, okay? So what it is they give you an equation that you're supposed to maximize, minimize something. Okay, normally they have a word problem and these are like dollars and we're trying to find the maximum amount of dollars, or talking about cutting pieces of wood and it gives us some rules that we have to follow. We want to get the maximum amount of wood that we can or something like that. So maximum number of board feet. So anyways, that's what this is talking about. So these constraints are like our rules, okay? So what we have to do is we have to graph all of those. So anyways, what you're going to have to do is take these constraints or rules and graph all of them, okay? So you take those constraints and rules and graph them. Now I know that it's going to be in this quadrant because it says that x is greater than 0, so that's everything over here. Y is greater than 0 is everything up here. So far the only place where those two intersect is in this first quadrant. Okay, so that's how I know it's in this first quadrant. So now I'm going to take the other equations and graph those as well. So it says y is greater than 2x minus 4. So I come down here to negative 4. I go up 2 over 1, up 2 over 1. So that dot's important. Up 2 over 1, up 2 over 1, up 2 over 1. Okay, so that's my line that I'm looking at. So there's that line. Now I'm going to graph this line. So I come up to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can really do this on your calculator as well. You can go down 1 over 2, down 1 over 2. Okay. And then you connect those. Now this line is greater than 2x minus 4, so it's everything shaded above the green line because that's the 2x minus 4. So it's in here, so greater than that. And then this line is less than. So we're talking about everything less than that, greater than green. So we're talking about this region in here. Okay, so this is my region where all of the intersections take place. I lifted my pen up so the shade doubled up on some of those. So this point right here, you need to label these points, is 0, 10. This point, we don't really know for sure. It's about right here, so that's 1, 2, 3, 4, 5.5 for the x, and 2, 4, 6, 7.5 for the y. Then this point, x is 2, y is 0, and this point right here. So notice I've taken all of the vertices. Okay, so I've taken all of the vertices and I've listed their coordinates down. So now if it says to find the minimum or maximum, either way, what we do is we plug them back into this equation, this master equation that they've given us, z equals or whatever, because this is the equation that we're optimizing. Okay, so what we're going to have is z equals 3 parentheses. So 3 where the 3 times x plus 2 times y. So I'm going to have, since I have 4 vertices, I'm going to have 4 of these. Okay, so I'm going to have 4 of these set up like this. And what I'm going to do is I'm going to put each vertex into these parentheses. Okay, so now I'm just going to pick these vertices, 0, 10, that goes in here. 5.5, 7.5, 2, 0, and 0, 0. So that's all four of these vertices that I've plugged in. Okay, and now 0 times 3 is 0, 0 times 2 is 0, 0 times 2 is 0, 3 times 2 is 6, 3 times 0 is 0, 2 times 10 is 20, 3 times 5.5 is 16.5, and 2 times 17.5 is 15. So that makes 31.5 when I add those together. So this is definitely going to be my maximum. So my maximum value is 31.5, and it occurs at 5.5, 7.5. My minimum value is 0, and it occurs at 0, 0. Now some of you are saying, well, it's always going to be 0, 0. Not if we have like a minus sign in here. Okay, so if I have a minus sign in here, like z equals this, then like this would be a negative 20, this would change to be 1.5, this would still be 6, and that would become our maximum, and this would still be 0. So realize that minus sign changes everything around in our formula that they give you to optimize. So be careful, don't just say, oh, the minimum's always at 0, 0. No, make sure you understand what's in here, plug in the points, get the values out, and then tell me that this is the maximum, this is the minimum. Tell me where it occurs as well, okay? So now to kind of show you how this works with a story problem, I'm going to do question number 22 out of your book. And they're kind of interesting problems to set up, so I'll try to work it through with you. I know you don't have to do it, but that's the best way that I can kind of show you how these work. So it says Guyton makes 24 hours tutoring chemistry. So $24 tutoring for chemistry, and $20 for tutoring math. Should charge more. It says let X represent the number of hours per week he spends tutoring chemistry. So we're going to call chemistry, it says let X represent the number of hours per week he spends. So X equals the hours here. And it says let Y represent the number of hours he spends tutoring math. So now we have that much, okay? It says write an objective function representing his weekly income for tutoring X hours of chemistry and Y hours of math. So what that's saying is, how many dollars is he going to earn at the end of the week? Well, he's going to get $24 for X amount of chemistry and $20 for Y amount of math tutoring. Okay, so now on part B, it says the time that Guyton devotes to tutoring is limited by the following constraints. Write a system of inequalities representing the constraints. So the first one, the number of hours spent tutoring each subject cannot be negative. So that means that X has to be positive and Y has to be positive. So they have to be bigger than 0. They cannot be negative. Due to the academic demands of his own classes, he tutors at most 18 hours per week. So X plus Y cannot be bigger than 18. The tutoring center requires that he tutors math at least 4 hours per week. So math is Y. So math has to be at least 4. The demand for math tutors is greater than the demand for chemistry tutors. Therefore, the number of hours he spends tutoring math must be at least twice the number of hours he spends tutoring chemistry. So he has to spend 2 hours for math for every hour of chemistry. Okay, so the hours of math, I think that's right. So if chemistry is 1, math is 2. If chemistry is 2, math is 4. No, that's not right. I said it right, but my equation doesn't match it up right. So see, when I plug in one hour of chemistry, or does that? when I plug in 1 hour of chemistry, so just watch. Here's what I'm trying to figure out how to explain, and I know what is happening in my head. So 2i, so see, that's saying that y is only half an hour. So that's backwards from what I need. So what I really need is 2x is equals y. So twice the number of chemistry hours is the amount of math hours. So that works better. So if I teach 1 hour of chemistry, I get 2 hours of math. Now that's working out. If I teach 2 hours of math or of chemistry, I get 4 hours of math. So now we've got our equation set up. So now I'm going to solve for y on each of these. So y is less than negative x plus 18. So I subtracted the x over. I'm going to divide. This one's already set up. Y equals 2x. Okay. Now let's see. The next part on this says, C, graph the system of inequalities represented by the constraints. So part C says we're supposed to graph this stuff. Two, four, six. I'm seeing if I have 18. 8, 10, 12, 14, 16, 18. Right there. So 4, 8, 12, 16, 18. So this says I go down 1 over 1. I don't know if I have enough this way. 2, 4, 6, 8, 10, 12, 14, 16, 18, right there. So down 1 over 1 means that my slope is going to, if I'm on the y-axis at 18, my x-axis is going to cross on 18 if I'm going down 1 and over 1. So there's this line. Okay, now this line says y equals 2x. Well, that means I'm just starting at 0 and I'm going up 2 over 1. Okay, so I'm going up 2 over 1. So I've got my lines drawn. Now I need a shade. So x is greater than 0 is everything over here. Y is greater than 0 is everything above. Now it says y is less than negative x plus 18. So that's all of this stuff. So that's everything shaded below this line. So that's everything shaded below. Now this one, the demand for math tutors is greater than the demand for chemistry. So really this should be y is greater than or equal to, because the math has to be, the demand for math is bigger than chemistry. It could be equal to, but for the most part it says the demand is greater than. Okay. So now that's got to be shaded above. That line. So the only part where it's all shaded is in this triangle right here. So we're going to use this triangle and the vertices of it, okay? So we're going to find the vertices of this triangle to plug into this to find our maximum amount given those rules that we have to follow. So here's one vertex, that's at 0, 0. Here's another one, it's up at 6, 12. And here's another one, it is 18, 0. So I'm going to plug those in. So I'm going to have z equals 24 times 18 plus 20 times 0. Z equals So I kind of stumbled with my breath right there because I was like, something's not right. And I realized what it is that's not right. I forgot to graph one. See this one that says y is greater than or equal to 4? I forgot that one. So y is greater than or equal to 4 is this one. And so that's shaded up here. So now I have this point and this point. So that's 2, 4 and 0, 4. And I wrote this one wrong. That's not 18, 0. That's 0, 18. That works better. So now we're sitting good. So anyways, I have these points. So I have 0, 4 is one, 2, 4 is another one, 6, 12 is one, and 0, 18 is another one. So I have 4 of them, so I'm going to need 20. I need 4 of these. All right, so I plug in the first point, 0, 18. I'm going to plug in the next one, 6, 12. Plug in another one, 0, 4, and plug in the last one, 2, 4. So I can go to my calculator, 20 times 18. 20 times 18 is 360, so this gives me $360. 24 times 6 plus 20 times 12 is $384. 20 times 4 is 80. 24 times 2 is 48, plus 20 times 4 is 80, so that's 128. So my maximum is going to be at 384. Okay, the minimum is if I only do 4 hours of math. So that's kind of what that problem is asking us to do. So that's going back to the page. So on 22 it says find the vertices of the feasible region. So we've done that. That's these 4 that are in here. How many hours tutoring math and how many hours tutoring chemistry should Guyton work to maximize? We should do 6 chemistry and 12 math. What is his maximum income? $384 per week. And explain why Guyton's maximum income is found at a point on the line x plus y equals 18. So this is the maximum number of hours he can work. So it has to be on that line because that line shows the number of hours he can work. So he can work up to 18 hours or down to 0 hours. So he can do 0 hours of chemistry and 18 hours of math. Okay, or he can't do 18 hours of chemistry, but he could do maximum 14 hours. Well, that doesn't work either. So it has to be on here in this shaded region. Because remember, it has to be twice as many. So all of these are going to be twice as many, like 4 hours of this, 8 hours of that. So 4 hours, this is chemistry, and this is math. So it has to be on this timeline right along here, because that's the number of hours that he can work. So for the maximum, it has to be somewhere along that line. So anyways, hopefully that helps understand how to do these problems. And sorry I got distracted with phone calls in between a few times and made a few mistakes, but hopefully that helps you and gets you going on that assignment.